Most of the time when you do a chemical reaction, you're not going to have reagents present in stoichiometric amounts, which is the amounts predicted by the chemical reaction. So most of the time you're going to have a lot of one reactant and not so much of the other. And so you're going to have reagents that are in excess. You're going to run out of something, stuff like that. Okay. So the typical type of problem that we deal with in stoichiometry is something where we run out of a reagent, which we call the limiting reagent. So the limiting reagent or reactant, however you want to call it, this is the reactant or the reagent that's completely used up first in a chemical reaction. Okay, so if the limiting reactant or reagent is used up first, the one that's left over is called the excess reagent. So the excess reagent, this is the material that's left over at the end of a chemical reaction. Okay, now in order to identify the limiting reagent and the excess reagent, we actually have to determine how much product is formed from each reactant. The reactant that produces the least amount of product is going to be your limiting reagent. And then how much reagent you have left over, you're going to have to work backwards from the moles of limiting reagent to moles of excess reagent to grams, subtract the final value from the initial value, and then voila. All right, so let's try a problem out. Okay, so here's our problem. The reaction between aluminum and iron 3 oxide can generate temperatures approaching 3,000 degrees centigrade and is used in welding metals. And here's your equation. 2 moles of aluminum plus Fe2O3 yields Al2O3 plus 2 moles of iron. In one process, 124 grams of aluminum are reacted with 601 grams of iron 3 oxide. Part A, calculate the mass in grams of Al2O3 formed. Part B, how much of the excess reagent is left at the end of the reaction. All right, so you're being asked 2 questions, and let's review that again. So the first question is calculate the mass in grams of Al2O3 formed. So this is the product of interest. Okay. Part B, how much of the excess reagent is left at the end of the reaction. So really, there's actually, even though there's 2 distinct questions being asked here, there's actually a third one that's actually implied, and it comes right before part A. In order to answer part A, we have to answer this question: what is the limiting reagent? So that's our question. We need to answer that. All right, so the way I'm going to answer that is pretty similar to what we just did with the last problem. So we want to know how many moles of Al2O3 can form from 2 moles of aluminum, and we want to know how many moles of Al2O3 can form from Fe2O3. So what we're going to do is start with a number. We're going to start with aluminum, and we're told that we've got 124 grams of aluminum. So we need to convert this from grams to moles. Okay, so 1 mole of aluminum goes on the top. The molar mass of aluminum goes on the bottom, which is going to be 26.98 grams. Okay, so that way grams of aluminum cancel out. Next, we need to convert from moles of aluminum to moles of Al2O3. So I need to put moles of aluminum on the bottom. moles of Al2O3 on the top. And according to this reaction, according to the ratio, you've got 2 moles of aluminum, and then you've got 1 mole of Al2O3. So let me change that 1. I need to put the 1 here, and I need to change that to a 2. So that way, moles of aluminum cancel out. All right. So this is where I need to stop. So I want to know how many moles of aluminum, of Al2O3, we actually have. So it's going to be 124 divided by the product of 26.98 times 2. The number I get is going to be about 2.29 moles of Al2O3. All right. Okay, so now we got to do the same thing with Fe2O3. So in the problem, we're told that we have 601 grams of Fe2O3. Okay, so we're going to do the same, pretty much the same thing that we just did with aluminum. We're just now going to do it for iron 3 oxide. So we have to convert this from grams to moles. 1 mole of Fe2O3 over the molar mass of iron 3 oxide, which is 159.69 grams of Fe2O3. All right, so the grams cancel out. We're in moles. And now we got to use the mole-to-mole ratio to convert from moles of Fe2O3 to moles of Al2O3. Now for this one, it's a 1-to-1 ratio. So 1 mole of Al2O3 over 1 mole of Fe2O3. So that's cool. All right, so that way the moles of Fe2O3 cancel out, and we're left with moles of Al2O3. So this is 601 divided by 159.69. The number I got was 3.76 moles of Al2O3 formed. All right, so to determine which one runs out first, we have to look at the number, the least amount of product that's formed. Okay, so aluminum gives us 2.29 moles of Al2O3. Iron 3 oxide gives us 3.76 moles of Al2O3. So since aluminum produces the least amount of product, our conclusion is that aluminum is the limiting reagent. Okay. All right, yay. All right, so based on this, now we can start answering some questions. So the first question that was asked is calculate the mass in grams of Al2O3 formed. So let's do that, part A. To answer part A, we already know we've got 2.29 moles of Al2O3 formed, so all we have to do is convert this from moles to grams. So for every 1 mole of Al2O3, I need to multiply this by the mass, the molar mass, and that molar mass is 101.96 grams of Al2O3. All right, so if I do that, the number I get is 233.49 grams. All right, but we need to report this with the right amount of sig figs. Since we had 3 sig figs in our numbers starting off, this has to also have 3 sig figs. So this is 233 grams. All right, so that's part A. That's easy. Now here's the other one. The next part was this. How much of the excess reagent was left at the end of the chemical reaction? Now this one's a little bit tricky. So what we need to do is start with a limiting reagent. Okay? Let's figure out how many grams of Fe2O3 did we actually really need to use for both reagents to run out at the same time. So look, you know you poured in way too much Fe2O3. How much did you really need to use for this chemical equation, for this reaction, for both of these to run out at the same time? So let's try this out. So we're going to start with the 2.29 moles of Al2O3 because that's our limiting reagent. That's how much product we're supposed to form. What we want to know is how much Fe2O3 did we really need to add. So we're going to convert this from Al2O3 to Fe2O3. Now that one was a 1-to-1 ratio. So 1 mole of Al2O3 on the bottom, 1 mole of Fe2O3 on the top. So that way we're out of the moles of Al2O3. We're in moles of iron 3 oxide. We need to convert this from moles to grams. So I'm going to multiply this. I'm going to put in our next fraction, I'm going to put mole of Fe2O3 in the bottom. On the top, we need to put that molar mass. Again, the molar mass of Fe2O3 was 159.69 grams. Okay, so that way the units cancel out. So if we take 2.29 times 159.69, that number I get for the answer should be 365.69 grams. Now, we're not done yet. So this number, this 365 grams, this number is the amount of iron 3 oxide that we need to add in order to have both reactants run out at the same time, so there's nothing left over. All right, so what the question's asking, though, is how much in excess do we actually have? How much did we waste in this chemical equation? So to do that, what we're going to do, we originally started with 601 grams of Fe2O3. Well, if we take that 601 grams and subtract it from 365.69 grams, this is going to tell you how many grams in excess you are. In this case, you have 235.31 grams in excess. Okay, so now this one, because this is our final answer, we have to report this with the right amount of sig figs. So this is going to be 235 grams. And there it is. So that's how you would answer this kind of a problem.